So I just got back from the post office, got the final package from Hobby King. Okay, here's some tires. These are the main wheels that I will be using. There should be 10 of these. I count 6 so far, that's 8, that's 10. Here's the nose gear retract unit. So this is the steering one. You can see it steers there. I think this one's the nose. This one has the double axle. These have the mains. We're gonna have to make the bogies for these tires, and then we have the last part, which is the XT90 connectors. So I'll have to solder these onto the battery and ESCs, as well as the ESC extension wires. So there's everything. The first order of business was to solder the battery connectors. And the way I did this was to cut both of the wires, but not at the same time. So I'd cut one, then wrap that with electrical tape, and then cut the other, and then trim the insulation off of one of the wires, figure out how much insulation that was based on the size of the connector, then tin the wire and the connector, put some heat shrink around the wire, and then solder the two together. And then after I soldered the two, I could put the heat shrink onto the joint and shrink it, and that would make a nice seal that would ensure that the wire wouldn't bend and break eventually, and it would also protect it against any sort of shorting out. And of course, repeat this 4 times, 1 for each battery. The next thing to do would be to make the main bogies that would hold 4 of the tires. The real XB-70 had these to support its immense weight. These were made from 4mm just either brass or bronze rod, and this is actually solderable, believe it or not. So I sanded down all of the rod on the ends and the shaft, and then I just applied standard electrical rosin core sort of leaded solder to it, and it seemed to solder very well. After this step, I ended up wrapping the joint in a bunch of copper wire and then soldering that just for extra rigidity, although it's not necessary, but it does add a significant amount of strength to the joints, and it does provide a fail-safe in the event that a joint should fail, because the wire will hold it in place. And I soldered the pin that goes through the leg. I soldered that slightly to one side from the center of the retract unit so that it would have a positive angle of incidence when the retract unit was lifted up. Also, the actual bogie is not removable from the strut once you solder it on, and here's a closer look at some of the joints. The next part was to grind a new flat in each of the retract mounting pins, because these had originally been designed for a sort of warbird style retract, where the retracts would retract from under the wing inwards to the fuselage. However, in this case, with the B-70, they would retract backwards, so I needed to grind a new angle or a new flat in the retract pin that was 90 degrees offset from the existing one. These are the retract mounting plates. The nose retract mounting plate was made from some thin plywood, I think maybe 1/8 of an inch or maybe 3/16, and it was just etched out with my laser cutter, which I later went over with a coping saw and a drill bit to get everything proper. The main mounting plates were made out of some very, very thick balsa. I think it's around 3/8, maybe 1/2 of an inch. It was constructed using the same method of lasering, and then instead of using a coping saw, I ended up just using a standard X-Acto knife. Now, to build the actual nacelle out of the foam, what I ended up doing is caddying everything in Google SketchUp, and then unfolding the parts using the rotate tool, and then exporting that to Inkscape, generating a laser G-code, and then cutting it on my newly built laser cutter. And what that allowed me to do is have machine-like precision where I would not have if I were just tracing it out onto the foam. So it enables me to have greater accuracy. However, one downside is that it doesn't cut all the way through. It only cuts through the top layer of paper and a little bit into the foam. It's very, very difficult to cut foam board with a laser from the experience I've had and other people on the forums have had. So it only does the equivalent of a score cut. But again, the accuracy is greater and it helps me a lot in terms of time. Assembly of the outer shell of the nacelle was very easy and used some flight test style methods, mostly just B-folds for the main section. And then I had a half-inch piece on the end of each individual section because it had to be split up into 3 sections, actually 4 sections, to fit on the sheets of foam. And that little half-inch piece would actually overlap with the next one once the foam was peeled off, and it would just provide a little paper sort of strengthening, reinforcing thing that would allow me to attach the parts better. The engine section, or at least the thrust tube outlet, uses an A-fold, and I sort of messed it up a little bit, if you can see. I did a B-fold on one side and A-fold on one side, but I was able to correct it, and it wasn't that big of a problem. And this is the nacelle prior to installing all of the intake ducting. To install the intake ducting, I had some specific formers that followed the contours of the outer shell of the nacelle, and I put the intake ducting in place and glued it in place based on those contours. And that's what you're seeing here for the left and right side, as well as the center. At the very front of the 2 pieces that made up the center ducting section, I beveled them off and then used tape to bring them to a nice sharp point like the real B-70 had. And now I'm just gluing on the little nacelle pod that sits right below the front of the intake and cutting the gear doors for that pod. I attempted to motorize these doors but was ultimately not successful. After I had installed the nose retract unit, I glued in a steering servo. The linkage between the servo and the steering arm on the nose retract used some little bits that I cut off of a control horn for a servo. So this is a test of the nose gear when the retract unit is up versus down. When it's down, you can see that the steering servo is allowed to turn the leg, and when it's up, you can see it just slides back and forth. So that means that your nose gear servo doesn't control and turn the wheel while it's inside the fuselage. And here I'm just installing the mains. The way I did this, and with the nose gear, is I elevated the actual retract mounting plate by some sort of box structure underneath it, and then I attached some sort of plate just on top of the retract that adhered to the sides. And on top of that, which I don't have a shot of here, I put a couple pieces of triangle stock or just some cross members. And this proved to be a very, very strong retract mounting option. Originally, I thought I would have to use some sort of plywood box or something, but this is definitely more than strong enough. Here I am positioning the retract gear door servos for the main units. Here's how the mains retract. First, the gear door opens, then the mains move, and then the gear door closes again. And the same is said for the nose. Hello. It is currently Saturday. I'm sort of tired of working on this plane. Can't figure out how to get the nose door retracts to work. I did get them sort of set up, and then as soon as I retracted the nose gear into the gear door bay, everything just broke. This wiring is going to be very difficult to figure out. Yeah, that's where I'm sort of sitting right now. I'm not sure what I'm going to do. I think I'm just going to try and finish this and then do something. Now we come to the problem of how long do my motor leads have to be. This is about 26 inches. Now we've got our 4 bunches of wire. Each bunch has 3 strands because it's a 3-phase motor. And now we need to strip the ends of these, tin them, solder bullet connectors onto one side for those motors, put some heat shrink over it, and then we need to solder the other end to the ESCs, as well as braid these. So let's get on that. The wire I'm using for the motor leads as well as the battery leads is 12 gauge solid core single strand wire. Now it's nice because it strips really easily. You just cut the insulation and it pops right off because the wire is perfectly cylindrical and there's essentially no friction between the two. The downside to the solid core wire is that it's very difficult to bend. It's not like multi-core where if you put it on a table or like on the edge of a table, it'll droop down. It is rigid, and especially at this gauge, it's not very easy to work with. The motor leads added about 350 grams to the weight of the ESCs, so I'm expecting that the battery leads will total that up to around 400-ish grams. Here I'm soldering the bullet connectors onto the wire. This was fairly simple, just put the soldering iron in the end of the bullet connector and then feed the solder through the hole on the side of the bullet connector. And that allows you to fill the entire thing with solder, and then you just shove the wire in it. And it makes a nice tight bond. Cover that with heat shrink and you're golden. So now that we've got wires going that way, we also need wires coming this way for the batteries. Right, I've got everything wired up, hopefully properly, and we've got 2 DFs all the way down there ready to test. And I'll just plug in this battery and let's see what happens. Okay, so both of them are making noise. Let's see if they spin up. Okay, so they're sucking air from in the middle and blowing it out the sides, apparently. So it looks like both of our ESCs are wired properly, so that's good to know. So now I just need to repeat this process again, and then we can get everything installed in there. And we should plug in the receiver. Okay, we got 2 motor tones. And both of them are spinning. So now all that's left to be done is to install these into the plane and get everything set up properly. So it looks like I actually made the motor leads a bit longer than they needed to be, so I'll have to go back and probably cut them in the middle and just resolder them, take out a section of wire. So that's going to take a while. So I figured you guys didn't want to see me solder those wires because you've probably already seen enough soldering in this build log. As you can see, what I ended up doing is these were the shorter leads, and I just ran these as they were, and then I took 7 inches off of the longer leads to make them the shorter leads. So now we have room for the ducted fans to fit, and all of the motor wires and everything are going to be long enough, if I can get that under there. I also cinched it all up with a load of cable ties, so the wiring is looking fairly organized right now. There's still an area in here, like the landing gear wire in here, that isn't so good, and then up here definitely could use a little work. I still need to get the front retractor gear doors working. I won't do that during this build log, though. I'll hold off on that because it's just going to take so long. But the main gear doors do work, so Yeah, I guess now is I have to laser out the thrust tubes and install the ducted fans. The next thing I cut were the thrust tubes. They had an outer diameter of 74 millimeters, which was the outer diameter of the ducted fan, and they had a 31 millimeter radius or 62 millimeter diameter exhaust exit, which was approximately, give or take a few percent, 100% of the fan swept area for my specific fan unit. And again, just like the Nacelle, these were CAD'd in Google SketchUp, exported to Inkscape, and turned into laser G-code by one of the Inkscape extensions. After this, I cut out the holes for the ducted fans as well as the thrust tube exhaust exit. The fans were attached just by putting them in the hole and then laying a bead of glue around the perimeter, as well as on the two tabs to keep it in place. And then after that, I put the bell mouth on the front and taped that in. The thrust tubes were rolled up and then just taped to the EDFs, as well as taped down their seams. And this is a perfectly reasonable method of attaching them. It seems to be fairly decent. At this point, it was about 12 in the evening, or the morning, depending on how you look at it, and I decided to head off to bed. I was greeted when I woke up at around 12. I guess that would be either the morning or the afternoon, depending on how you look at it, by the fact that all the snow had melted. So that meant I had a nice day for a taxi test. This is about as far as I got last night. I got the ducted fans installed, the thrust tubes installed. Basically everything is ready to go except for the front retract gear door servo linkage units. But now we need to take this thing outside and just taxi test it, and then I might bring it back inside and then do just a static thrust test. I'm planning on putting the batteries in here to weigh down the nose so that so the batteries will just go in here for the taxi test. When I actually do put the batteries in the plane, I'm thinking some of them are going to be up in the neck and some of them are going to be maybe here or slightly above here. It depends on where the CG has to end up, which I'm not exactly sure about yet. I'm also going to need to put some little covers here. I didn't account properly for where the gear would end up, so there's a bit of an outcropping here. It shouldn't be that much of an impact on the performance of the fan, but I'm going to have to put just a little shroud around this so that the fan isn't trying to suck air through the gear doors. So that's the plan for the next build log, but for now we need to get to taxi testing this thing. First order of business is get the batteries in here, get it all plugged in, powered up. So that's what I'll be doing here. Okay, so that should be 4 ducted fans. I think my mains are a bit out of alignment. But it does taxi. That's very interesting. Oh, that's awesome. After I completed the failed taxi test, but successful thrust test, I took the nacelle and I put all of the other parts on it. In just a general mock-up, not their final position. I'll have to cut some slots for the V-stabs and screw the wings in properly. But the point is that this thing is freaking huge. It doesn't even really show on camera how big this is. It's just a beast of a bird. and I'm looking forward to seeing this thing fly. This episode is longer than I would like it to be, at around 20 minutes, whereas the other ones have been 10. This was done over a period of about a week. Anyways, I think that about wraps it up. Like, comment, subscribe, you know the deal. YouTube's algorithm favors audience retention as well as audience interaction now, so yeah, that's about it. And I'll see you guys next time.